The most surprising solar system fact is that the planets are not the main story. When we picture the solar system, we usually imagine Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune lined up like a neat family portrait. But almost all the mass in this system is locked inside one object, the Sun. The Sun is not just a bright lamp in the middle, it is the gravitational anchor. Its pull keeps the planets, dwarf planets, comets, asteroids, and distant icy bodies moving around it. Without the Sun, there is no solar system in the way we know it. There would just be scattered worlds drifting through the galaxy. This changes the scale of everything. Jupiter is enormous compared with Earth, but beside the Sun, even Jupiter is a small companion. Earth is smaller still, a rocky world warmed by a star powerful enough to shape space across billions of kilometers. What is known is clear. The Sun dominates the solar system by mass and gravity. What is still studied in detail is how that solar influence changes over time. The Sun has a magnetic cycle. It sends out a constant stream of charged particles called the solar wind. It can stir up space, weather paint, auroras, near planetary poles, and slowly shape the environments of worlds and moons. That matters because the solar system is not just a collection of separate objects. It is a connected system with the Sun acting like the central engine. The memorable takeaway is simple. We live in a planetary neighbourhood, but it is really a star's domain. Every orbit, every season, every comet's return begins with the same quiet truth. Our solar system is not centred on planets. It is centred on a star, and that star sets the stage for everything that follows. The solar system is much larger than the path of the 8th planet. Neptune feels like a natural edge. It is the farthest major planet from the Sun, cold blue and remote. But beyond Neptune, the solar system keeps going. Out there is the Kuiper Belt, a broad region of icy bodies. Pluto lives in this outer zone, along with many smaller worlds that are leftovers from the solar system's early construction. They are not failed planets in a simple sense. They are frozen records preserving clues from a time when the planets were still forming. And farther still, scientists think there may be an even more distant shell of icy objects called the Oort cloud. It has not been directly seen as a neat boundary. Its existence is inferred from the paths of long-period comets that fall inward from deep space. So this part of the solar system is real science, but also honest detective work. What is known is that the Sun's gravity reaches far beyond the planets. We learn, first. What is uncertain is the exact shape, population, and history of the most distant regions. We know the solar system has outskirts. We are still learning how those outskirts are arranged. This matters because the outer solar system is like a cold storage vault. It may hold some of the oldest material available to study material that did not get melted, reshaped, or buried, the way rocks on active planets often do. The takeaway is that Neptune is not a wall. It is more like the last bright streetlight before the landscape becomes darker and stranger. The solar system has a familiar inner story, but its far edge is still a frontier. The deeper lesson of the solar system is that worlds are experiments. Earth, Venus, and Mars all formed in the same broad neighbourhood around the same star. They are all rocky planets. They all began with heat impacts, chemistry, and changing atmospheres. Yet today, they are dramatically different. Earth has oceans, active weather, and a biosphere. Venus is wrapped in a dense heat-trapping atmosphere. Mars is cold dry on the surface and marked by evidence that water once shaped its landscape. These differences are not just trivia, they are clues. Planetary science works by comparison. Scientists ask why one world kept liquid water, why another became so hot, why another lost much of its atmosphere, and how moons, rings, magnetic fields, and impacts shaped each place. No single planet explains the whole story. The power comes from studying the family together. What is known is that planets change over time. Atmospheres can escape. Surfaces can be renewed or frozen in place. Impacts can alter histories. Moons can heat their interiors through gravity. What remains uncertain is the exact chain of events that made each world the way it is today. The evidence is strong in many places, but the full history is still being reconstructed. This matters far beyond our own neighbourhood. When astronomers find planets around other stars, they use lessons from our solar system to ask better questions. Is the planet rocky or gaseous? Is it near its star or far away? Could it have an atmosphere? What processes might shape it over billions of years? The memorable takeaway is this: the solar system is not a finished museum. It is a living archive. The sun gives it structure. The outer frontier preserves its beginnings, and every planet tells a different version of what a world can become.